Yeah, I
Yes,
think you're
that's
good to
fine.
go.
Great. So I'm going to talk about JavaFX Performance because Wolfgang has asked me to do that. And I recently also had some requests to do something about JavaFX Performance, so it fits perfectly. And since it's a really, really big topic, I'm only looking at a very small part of it. I'm Tony Epple. I'm the creator of DukeScript, which is also Java front-end framework, which is very nicely integrated with JavaFX. So you can actually use it with JavaFX properties and embed it into your JavaFX application to also add web content there. It's something really nice, but it's not the topic of today's talk. I've been working as a JavaFX consultant and before that as a Swing consultant for a very long time. And I've been working on large applications mainly. And some of these tend to have performance issues. While JavaFX is really nice and fast, when it comes to Java performance tuning, it's a bit stubborn. I'm going to talk today a little bit about how the JavaFX architecture influences that and what tools we can use to actually get some more information out of it, because it's actually a bit better hidden than in other frameworks. So in JavaFX, we have the JVM, and then we have the lower levels, the rendering pipelines. We have Glass and Prism. We have media and web. We won't talk about that today. Above that, we have the Quantum Toolkit, and we have the public API. So the part where the actual rendering takes place is quite well hidden, because usually you only interact with the public API. And since JavaFX is also based on a scene graph, you're not issuing graphics commands directly to the machine. But you're basically creating a scene graph, you're changing some properties of some nodes, but you're not actually issuing graphics commands yourself. And that makes it a bit difficult to find out if something goes wrong. Usually it doesn't go wrong, and JavaFX has really good performance for most use cases, but sometimes it's also, there are issues. So the nice thing about JavaFX compared to immediate mode rendering frameworks like Swing is that it has a really simple API, and you do not have to optimize that much. The system can optimize a lot because it has the whole information. It has the whole scene graph. It has all the graphics objects, and it can do stuff like occlusion culling or clipping, whatever. And depending on the skills of the developers of this scene graph API, this can be quite fast. It only requires to process changes. You make a change to a property, then the system knows, okay, we probably need to inspect the scene graph to see if we need to re-render something. So that's also really nice. But on the other side, it also requires a little more memory, because in immediate mode rendering frameworks, where you basically store the model of your application, of your graphics objects yourself, you have a little more influence about how this is stored. And you do not have these nodes. In JavaFX, you have the nodes for everything. But since the machines are gaining memory, are getting better and better, for the M1 chip, for example, they complain that it's only supporting 16 gigabytes of RAM. You can render a lot of nodes with that. So that's not that big of a concern anymore. There's a bit less flexibility in some aspects. For example, I remember that one of the first things that Gerrit Grunwald did was creating gradients and cool stuff. And he was creating these watch-like meters and controls and gauges. And one of them had a conic gradient as background. And since he wanted to make it scalable, he tried to do that with nodes, and that was quite difficult because it wasn't supported at that time. So some problems, some things are easier to do in an immediate mode rendering way, but for that we now have the canvas node, so we can do that stuff as well. It's not that big of an issue. But what is really a little bit more difficult is when you have performance problems. They are slightly harder to track than in other frameworks. So, and to understand what is actually happening and how we can get to this information, to the relevant information, I would like to introduce how it's actually working, how the pulse of the application is working, and how the rendering pipeline is working. The JavaFX pulse is fired by a dedicated timer thread, which fires every 16 milliseconds. And it calls this method quantum toolkit post pulse, and it posts it under the following conditions. If there is an animation running, then the thread is the timer is fired. If there are dirty scenes, then the pulse is fired. If the pulse has been requested, the pulse is fired. Or the last thing is, if these are true, but the previous pulse is still running, then it's skipped. Then it's not running. Then it's not fired. These are basically the four main conditions that the timer thread looks at in order to decide whether to post the pulse. And the JavaFX pulse consists of several phases. The timer thread starts the pulse, and then the first phase is run animation. So all animations are evaluated, and the values are changed and adjusted. Then the CSS pass is done. After that, we do a layout pass. Then we do update bounds, and then we have a wait phase, wait for rendering to complete. And this is actually not rendering our current pulse, but this is waiting for the last pulse, because since JavaFX 8, this is concurrent. So before that, it was basically, you could call it single-threaded, because the render thread was only running when the FX thread was stopped. And now it's more concurrent, and therefore we need to wait, because the next phase is synchronized scene nodes. And synchronized scene nodes does exactly that. It takes the nodes that are in our scene graph, looks at the properties, and looks what needs to be put into the peers, into the native peers in the rendering pipeline. Because the rendering pipeline, which is based on OpenGL or direct draw, or it's the software pipeline, this rendering pipeline has basically a copy of the scene graph with native objects, and we copy our state there, and then we start the rendering. And since we cannot do that while the rendering is still running, because we would mess up everything, we have to wait for the rendering to complete. And after that, we are ready, we are fine, we can add the render job, and we can start the render thread, and it will start with the painting phase, and after that, we have the presenting phase. And that's one full pulse. If these things are running concurrently, you can see the timer thread here. You also see the arrow down. It fires a pulse. And then after a certain time, after 16 milliseconds, you see this, this second blue line that is the attempt to start a new pulse. But we can see the pulse is still running, so it's skipped. And then the pulse ends. We can process some input events, which are also processed on this FX thread. And then the next pulse can start at 32 milliseconds after the first one. So we skipped one pulse. And you can see in the meantime, while the first pulse was running, the old pulse was still rendering. And at these yellow boxes, both of them are basically synchronized, and we can start with a new rendering job. So that's the most important part that you need to know about how JavaFX works, because in some of these phases, something may go wrong. And if you look at the information that the system will give you, you can figure out what it might be. You get a good clue what it might be. So Again, we are using a 16 milliseconds pulse. That means we can reach around 60 frames per second. That is the default setting. Because that's what current monitors have as a refresh rate. So typically it's around 16 milliseconds. It's not 60 milliseconds exactly. Sometimes it's 15, sometimes it's 17, because we want to reach 60 in the end. So if you go about tuning a JavaFX application, and if you want to get more performance out of it, the traditional approach is to use the typical tools. So if you go in a very structured way, you try to find the dominating consumer of your CPU. You want to find out, is it user or system? If it's user, you use these tools. If it's system, you use these tools. And you end up maybe, if you're on the Java side, using a profiler or GC logs or something like that. In a JavaFX application, that won't help you that much. CPU profiles are not very useful. There's a lot of wait time due to interaction with GPU and render threads. There's lots of GC because nodes are thrown away, but it's not usually a problem. So CPU utilization is quite misleading in JavaFX applications. And because the scene graph does all the rendering and everything, most of the things that you see are actually graph traversal. And it's really hard to find out what part of your code is causing these operations, and it's really very hard to spot your node inside these profiles. It's basically near impossible. So luckily, there are some JavaFX specific tools that we can use for that. And this is going to be the main focus of this talk, to get you to know these tools, because I know from my professional experience that actually at most companies, nobody uses these tools because they are guessing what it might be. Sometimes it's good, sometimes it's educated guesses. Sometimes you look at the application and you see some certain kind of effect, and you can already guess that this is probably the cause of a performance problem. But if you want to go more structured approach, it's really good if you know these kinds of tools, especially when they allow you to measure how long your pulse takes, what frame rate you get. And the tools we are going to look at is Performance Tracker, Pulse Logger, and JDK Flight Recorder with Mission Control. Performance Tracker is the first one. It's also the simplest one, and it's on the highest level because all it does is analyze frames per second. It gives you the ability to execute code depending on a pulse, but yeah, mainly it does measure frames per second. And unfortunately, it's no official API. So in Java 9 Plus, it's not supported. It's in a ComSun package. The export requires configuration in compile and run configuration. So you basically need to do an add exports and export it to your module. But if you do that, that's just fine. And in module info, you need to require JavaFX graphics. So the performance tracker itself is updated directly from the scenes pulse method. So it's really at the heart, implemented at the heart of JavaFX itself in the source code. And it has a method get scene tracker, which gives you a tracker for a specific scene, because frames per second relate to this specific scene. And from it, you can get the average frames per second, which would be the frames per second since the last reset, or the instant frames per second, which are the frames that you got in the last second. I'm usually using Maven for creating applications, and yeah, for JavaFX, I make no exception. There's a nice plugin from the Gluon guys, I think, originally, or at least there are a lot of them working on it, and it's really nice and it works well. You can find it on OpenJFX.io, and there you can also find information how you can configure it. but it's quite simple to use. You just add it to your Maven POM, or they even have a Maven archetype. It's not in Maven Central, but so you have to clone it, you have to build it, but then you can use it to create new applications. And in your configuration, you can see here, you have these options, and you add the add exports, JavaFX graphics, ComSan JavaFX Perf, and this is the name of my module. And then I have the main class and I start it. And to use it, I have this simple example. I created a label. And for this label, I create the performance tracker via this method getSceneTracker, passing in the scene. Then I create a timeline and let it run indefinitely. And I want it to fire every second to update the label every second with the current frame rate. So you can see here in the handle method, I'm updating the scene tracker label with the instant frames per second. Okay, that's it. I add a keyframe for that, and on the end of the keyframe, this method, this handler is fired, this unfinished handler, and I start the timeline. And next, I simply create a label, and I show this label on the screen. There's nothing fancy here. There's nothing JavaFX performance tracker specific here. So let's have a look how this works. So here's the application. And you can see here we have our application. It's running. It's showing the text, hello JavaFX 13, running on Java 15. And you can see the current frame rate. It's around 1 frame per second. That's a bit surprising because we want 60 frames per second, right? So I need to check if anyone is online, and this is a good way. Can you still hear me? Okay, so what's the reason why we only have 1 frame per second? Does anybody know?
Yeah. There is no animation running and nothing that's causing a pulse.
That's exactly it. There's nothing that is causing a pulse. There's no animation running. And if we recap, the timer thread only fires when there is an animation running, when there are dirty scenes, when the pulse has been requested, and none of that is actually happening. But still, should the frames per seconds not be 0 in that case? Why is it 1? Does anybody know?
If I can guess, if there's any state that has changed, so it has to check if there's any property state that has changed so that it can update the UI, probably.
It's hard to hear you, but I guess it's if you said it's because we are firing an update every second to update the frames per second, the label, then you're right. So that's the reason, because we're actually doing an update once per second. We're changing the frames per second label. So frames per second can be a little bit misleading. So if you just use the performance tracker and put it somewhere on your screen, most of the time in a controls-based application, there's not so much happening. So it's perfectly fine if you only get 1 frame per second or 0 frames per second, because that's actually what you want. You don't want to do too much work in your application. You don't want your computer to do too much work. That's basically good programming. Another way to do it, to get the frames per second, is to use the animation timer, which is a class that is in the official API, but it requires you to calculate the frames per second. So I prefer to use the performance tracker because it's simpler. but if you create a library once and based on animation timer, that's fine as well. But the animation timer has one big difference because it fires all the time. So it will actually give you the 60 frames per second. So you will see the 60 frames per second because the animation timer itself forces the system to fire all these pulses. So let's have a look at the application using animation timer. So in this sample that I created, I've added a small animation timer, and this animation timer is updating our label. And we can run the application again. And this time it should update. So let's see what it does. Yes. So we're getting a frame rate around 60 frames per second. That's exactly what we would expect because we're not doing that much rendering in here, and everything is fine. So we get our 60 frames per second. Our performance is okay. But this is not max performance because actually we're not doing very much and our pulse is not really taking that long. So we're basically waiting for the timer thread to fire the next pulse. If you want to really find out how fast your application and how fast your animation can go, there's a command line switch for that. And that's JavaFX animation full speed is true. And we can enable that again in the POM. Let's do that and run the application again. And I would guess we get a lot more than 60 frames per second. Okay, so yeah, we're around 400 frames per second right now. And we're doing updates also all the time. So the application is updated. You can see the counter is going up. So you can see JavaFX itself can go a lot faster than 60 frames per second, but it does not really make a lot of sense to run it faster than the screen refresh rate. So if you want to just measure frames per second, performance tracker animation timer is great. If you want to look inside the pulse, there's a different method, and it's pulse logger. And the pulse logger gives you really insight into how the pulse phases, how long the pulse phases are. So you can get the information how long the CSS pass takes, how long your layout takes, and this information is really valuable. It gives you additional information, and you can even extend it. So there is one class that is called logger inside of the JFX. And there are actually two implementations, and we will look at two implementations of it. And the two implementations are for two different purposes. So right now we're looking at implementation that is called the print logger. And the print logger just prints out this information on the command line. So it just goes to standard out and prints you information about the pulse phases and the pulse frequency and the speed that you're getting. And it also can give you information about input events. Well, not the print logger directly, but we will see how we can get there. So to enable the pulse logger or the print logger, which is the implementation, you just pass JavaFX pulse logger is true. And you can set a threshold. I think the default threshold is 16 or something like that, because you're only interested in events that take longer usually than the 16 milliseconds. So you are only interested in events that make you skip a frame. And this pulse logger output gives you information. We can have a look at it. I have prepared a small application. You can see here, let me see. Yes, we are. So this is the relevant command line switch here. And here is the threshold. And this is something different. We will look at that a little bit later. So let me run the sample. So in this sample, we're doing a little bit more. And this sample, I don't know if you can see the animation. It's actually not running at full speed. It's not running at full speed for various reasons. One of the reasons is probably that my machine now processes the video of the camera, processes the screen scraping, and processes the video that is coming back from Zoom. But you also get a bad frame rate of around 45 if nothing else is running on this machine. So let's have a look. You can see the output. And you can see we're missing a lot of, we're skipping a lot of frames. And what you can see here is usually you only see these intervals. But if a pulse is too long, then you see this full information here. And this full information gives you the information that this is pulse number 864, that it was started 50 milliseconds after the last one, and that it took 76 milliseconds to complete. You can see there are two threads, thread 18 and thread 15. And thread 18 is our JavaFX thread, and thread 15 is our render thread. So you can see the passes, you can see the phases of the pulse. You can see CSS pass was fast, layout pass, we have no layout there. Update bounce was fast. And then we're waiting 39 seconds for the last pulse. And well, that's probably already the reason why we missed the pulse. But again, you see that's there's a lot of stuff going on, and it's rendering a lot of stuff. It's rendering 13 out of the 14 nodes that are on the scene. And this is the information that that the pulse logger can give you. It also gives you a little bit information about what are the dirty regions that have been updated, that had to be updated. Sometimes there's one dirty region, sometimes there are more than one dirty regions, sometimes everything has to be updated. So again, let's recap. This is the JavaFX Pulse. We have these faces, and we saw all these faces basically in the output from the pulse logger, except for run animation. But you can actually, you can interpolate how long the run animation must have taken, because if you look at the output, you will also, let me show it to you. You will also see, like, for example, if you look at the first line that starts with T15, you see there's a 0, and that's the time since the last phase. So this one started 0 seconds after the last phase, which was run animation. But if there are complex animations, if you animate thousands of nodes, then it takes maybe 3 or 4 milliseconds before the CSS pass actually starts. So you see all these phases that I mentioned to you in the actual output. So usually, if everything goes right, you do not see what we've just seen. You see something like this instead, because this just gives you some short information about each of the layout of the pulses. It gives you the number of the pulse, it gives you the number, the time since the last pulse, and it gives you the time it took for this pulse. So this is an application, probably it's something like the application that I've shown you before, because it only takes 1 millisecond for the whole pulse, and the rest of the time the thread, the FX thread and render thread are idle. So again, we already looked at this kind of output for a pulse that exceeded our time budget of 17 milliseconds. And again, you can see here the number of the pulse, the time since the last pulse, the time for this pulse. And you can see in this case, we exceeded our budget in painting. So in the render thread, something was difficult to paint, obviously. And we have slightly more nodes apparently here. So something went wrong here, and we skipped one frame. In addition to these phases, you usually also get information about a little more information about what is going on internally. So what are the different dirty regions? So the scene graph optimizes, and it does not repaint everything usually, but it identifies the dirty regions and only repaints these. And you get this information as well from the pulse logger messages. Some other pulse logger messages that you see frequently is cache filter rebuilding. That is a so-called counter. So they usually are at the end of the output, just like here. In the end, you have the counters, nodes rendered 69, nodes visited during render 69. And just like that, you may have a cache filter rebuilding output. And that is put out when we need to render the cache. That can happen if either the wrong render cache hint is set. So you can set these cache hints to basically ask JavaFX to take a picture of your node after it's first rendered, and then it's in the cache in the cache. And after that, it can take this picture out of the cache and reuse it. And there are some hints that you can use, and it's very smart to use those in animations because it really speeds up things a lot. And you can hint at the system what you're going for. For example, you can say like, it's okay to use the image from the cache, even if the node is scaled, even though this usually means that the node should be re-rendered because it's scaled, so something new has to be made. But if you say like quality isn't so important because the node is moving very fast and the animation is going very fast, so nobody will notice, then the cache hint is perfect. And if we need to rebuild the cache, then you will get this information, and it's a good indicator that maybe you should set a different cache hint. Then you have slow background path for null. That is when the edges of the background are not uniform and each edge has to be rendered independently. We have slow shape path for null that you see sometimes, and that is also happening when you're drawing the background shape without the cache, or if the cache is present but the background is scaled, it's getting bigger or smaller, so it has to be repainted. The nice thing about this is really useful information, but sometimes you need more of it. And you can actually enhance logging by adding your own information. And this requires you to custom build your JFX. It's not that hard. You can go to the wiki, open jdkjava.net, and it will show you how to build JavaFX for your framework, for your platform. And in my case, for Mac OS X, the last time I built it, probably this has changed in the meantime, but last time I built it, I had to install an old Mac OS X SDK. But these are available on the web, and there are some infos how you can do that. As I said, probably you won't need that anymore. Anyway, so if you want to use your local SDK, you have to tell Maven. So in the properties, you can set the path to your local SDK, and in the dependencies, you can depend on it. You just have to set the scope of the dependency to system, and you have to give it the system path to the jar. And I will try to reconfigure my sample. By the way, let me switch to Zoom. So how is the time? How much time do I have? Am I good in the time? Am I bad?
How much more time do you need? I have no idea based on that if you are good or bad.
Okay, I have not exceeded the time limit that you've set for me.
No, you have 3 more minutes, then you're in schedule, but you could have some more minutes if you want.
Okay, 3 more minutes, is that true or are you joking?
No, in 3 minutes we at the regular end, but as said, we're totally fine if it takes longer. I have no idea when you started, to be true, so
okay.
yeah.
I didn't. This is the first time I'm giving this talk. I'm really of trying to condense this into a very small amount of.
People are saying we should keep you talking because that's interesting. So I've said nothing. You have all the time you want and need.
Okay, great. Thank you very much. So let's have a look. So I'm now in the repository where I built my JFX, and I can now look what I did. So this is the class that is actually responsible for making all this great output. Sorry, I wanted to do a git diff so we can see what I changed. So this is the class print logger, and it extends logger. As I said, there is another implementation that is interesting, and we will look at it. And interestingly, the print logger in the default system does not implement the method new import, or does not override the method new input. So I did that, and doing this, you can get logging when an input event happens, which is quite useful sometimes. It's also very noisy. So let me disable this, and let me enable the system dependency. And let's see if it works. Okay, the application is running. That is good. And you can see it down here. When I'm moving my mouse, when I'm doing something, I get all these input events. And that may be quite useful because it helps you to also time, for example, if you click a button or something like that, you can see that in here, and you can then relate the frames better to what you're actually seeing. I like to use that. Sometimes I disable it from a command line switch, but for this I took out the command line switch to make the code simpler. And the next thing that I'm using it for is actually very useful. And well, what you can do in Pulse Logger, it actually has an internal API that you can use to create your own counter. And you just say Pulse Logger increment counter and give it a name. And then this counter will actually show up in the list of counters at the end of the Pulse Logger output for a frame that exceeds the limit that you set. So that is quite useful, and I hope I can show it, because one of the things that I've been talking about is cache and cache hint, and I already told you that it's often a very good idea to set a cache hint, and I will be doing that for the nodes that I show in this application, and it should probably make the application a little bit faster. But that's actually not the whole reason why I'm showing it. You see, the application is much faster, even though everything here is running. I didn't expect that, actually. Everything here is running. All the video streams are processed. I get a frame rate of 60. That's pretty good. And that's not what I want. I want it to, well, let's see if I can get some frames to skip. Yes, here we have it. You can see now here in the counters, I have my own custom counters. I have here, that is really nice. I see I have a cache hit because it was just a translation. That's fine. I have another cache hit. It's a scale and rotate hint that I set. So obviously I did everything right. I did, but it also reports cache misses. So if I use the wrong cache hint, it will report here, and it will tell me, because this will probably influence how fast the pulse is going. But it's very nice. we already did everything right, and we have 60 frames per second, so we don't have to care about that anymore. And I will show you again where I did that. In git diff, that's the class here, cache filter. And cache filter is also a class in the system. And here I created a couple of, I'm doing the counters. So here is a method where I see if cached image data is null, then I need a cache rebuild because there is no cache data yet. Then I increment the counter cache rebuild due to translation, cache rebuild scroll cache disabled, and I have all these output events that really help me when I go to a customer and he has issues inside animations or something like that. I just run the application with my own custom built JDK, JFX, and I get a lot of information that is very hard to get otherwise. So that's really convenient, actually. And yes, you have the custom counters here. Then there is last but not last, actually. There is also a set of command line flags that are really useful. So, for example, prism verbose is true. That gives you info on the graphics pipeline. On the when the application starts. Then you have prism show dirty is true, which actually shows you graphically where the dirty regions are. I have to show you. Hendrik, you stop me if I'm taking too much time, okay?
Yep. I will listen to the audience. They say you should continue.
Okay. Thank you very much, audience. I appreciate that. Okay, let's run the application again. Command execution failed. Yes, because I have white space here where it doesn't belong. And you can see these red areas, and these red areas show you the dirty rects, which is also really nice and quite convenient if you're debugging your application. I won't show you the other ones, but I will talk about them. So show overdraw, for example, is actually showing you different colored rectangles. For green rectangles for the ones that are drawn more than once. And one also very nice and very, very useful one is disable effects. Because a lot of time there are expensive effects in your application, like shadows, drop shadows or something like that. And if you put those in animations, it might really cause performance degradation. So if you add this command line switch, disable effects is true, then all the effects will be disabled and you will probably see a better performance. And if it's the case, you will see, you know that effects is the reason. So the last thing I will show you very shortly is JDK Flight Recorder and JDK Mission Control, which are really great tools independent of JavaFX and which have JavaFX specific extensions. JDK Flight Recorder is coming from the JRocket mix with JDK, and as well as JDK Mission Control. JDK Mission Control is Eclipse RCP based visualization of the output from the JDK Flight Recorder. And the JDK Flight Recorder is a high performance event recorder. Sorry, I'm going too fast now. That is built into the JVM and which allows you to, with a very, very little overhead, to profile your application while it's running. So it's really, really good. It's a single self-contained binary file, and it gives you very detailed information. It can run in production. Some really suggest to do it because you can really debug applications in production. It's using JMX to so you can actually instrument the virtual machine and start a recording from inside the virtual machine, get the recording and analyze it outside, and the application will basically run at full speed. There is some tools for Java Mission Control for JDK Flight Recorder called the most important one is Java Mission Control. Visual VM can also read flight recordings, but Mission Control is actually the best tool. And there are Java APIs for recording custom information. And there's an extension, a plugin that records information for JavaFX. And I told you before that the pulse logger, the logger, has two implementations. One of them is the print logger, and the other one is, I think it's called JFR logger. It's also in JavaFX directly, so you don't have to install it. It's already there. And if you're running, if you're doing a recording, Java flight recording, you will get information about the pulses and about input events, because the flight recorder JFR logger also records input events. It used to be there. It was introduced in JDK 8 and reintroduced in OpenJFX 12. So it's available now. And I think I can show it with my application. And that's the last demo that I will do for today. So let me start the application, and I'm looking for JDK Mission Control. So the application is running. And here in the JVM browser, I can see somewhere my sample. That should be it. And I can start the recording. And let's say, I don't know if I can set it smaller than 30s. Yes. And let's see if that works. So we're recording stuff for a couple of seconds. I will do some input events, some clicking, and you can see down here, it's doing the recording. It's at 30% of the recording right now. And let me put a little bit stress on the system. Yes, I can degrade the frame rate. That's great. And now let's wait until the 30 seconds are over. And it's done. I can shut down my application, and I can see here the analysis is running, and you can see a lot of stuff, like how many threads you have, a lot of interesting stuff, but it's not what we are interested in. We are interested in this. This is a JavaFX specific plugin that you can download and install. So if you install it from OpenJDK, there's already an update center integrated, so you can directly install this extension, and this gives you the exact same information about the pulses. So like, let's have a look at this pulse here. You can see here the phases. So I also recorded the stack trace here, and you can see, if you mouse over it, you have the different phases. That's the render thread. That's the JavaFX application thread. And you can see this is the layout pass phase. It's very short, so you cannot really see it very well. And then we have the copy state to render graph. So these are the same pulse phases that we've seen before. And you can see them together with statistics about the input events. You can also see the input events here in the JavaFX application thread. You can zoom in and out and look at a couple of different threads. You will always see the information about the threads that took really long. Those are the most interesting ones, like this one here, where we're spending a lot of time, 140 milliseconds on the event thread. And so this is a great way of analyzing the pulse in a graphical way. So it's the same output that you're getting from the pulse logger, but in a much nicer presentation. So you can get all this for free. Actually, you can download it. The JMC Mission Control is on GitHub. and there are ready-built versions. For example, this one, JDK Java.net JMC. That's where I got it, and that's where I also got the JavaFX plugin. So it's really cool, and yeah, I hope I tried to cram as much information as I could into this short amount of time. There's a lot more to learn. If you want to do it, let me make some advertising, because last week somebody asked me if I want to do another JavaFX performance tuning workshop. So if you want to join, it will be on January 26th. And you can contact me on Twitter via my handle Monaco Tony, for example, or via the Appleton site. So that's it. I hope I was fast enough now. Hendrik.
Yeah, everything's fine.
So it's time for beer. Cheers.
Yeah, I already said that while you were talking, I already got a beer and some chips for the after conference session.
Very nice.
But Tony, there are some questions.
Yes.
So so people. So let me see. Wait. So do you know why they decided to use a single thread for JavaFX instead of having a multi-threaded approach?
Well, it's actually multi-threaded. So what you saw is you have three. It's actually triple threaded. You have the timer thread, you have the FX thread, and you have the render thread. And in the original Java FX 1 and 2, it was basically single-threaded, even though these threads existed, but it was basically single-threaded because the render thread and the FX thread didn't run at the same time, because it's difficult to do that for some reasons. I don't know what the reasons were, but I was talking with some guys who implemented that that stuff, and they said it was difficult to get it to run in parallel. But now, most of the time, the FX thread and the render thread are running in parallel. It's just like this small amount of time where they're actually synchronizing. So the paint and present phase are actually running in parallel to the next thread. And only at this, yeah, you remember the yellow box? The yellow box is the point where it's synchronized and where the where the FX thread has to wait for the render thread to finish so it can copy the new state to the native peers, to the native nodes, to the native scene graph, so it can be rendered. But it's running in parallel, and I think using more threads than this has worked for no graphics framework I have heard of. There have been some attempts to create really parallelized UI frameworks, but as far as I know, all of them failed.
Yep. Okay, another question is about rendering hints for caching.
Yes.
So there were a lot of discussions, questions. When to use what hint? Some people said, when I use them, the animations even get slower. Do you have some best practices here?
Well, I look at what kind of stuff I'm doing. If I'm doing a rotation, I set a rotate hint. If I'm doing scaling, I set a scale hint. But I'm not so well. I go for the big gains. I usually set cache hint speed, which is basically everything.
Okay. Cool.
But usually, so I'm surprised that performance should degrade when you're setting a cache hint. I'm not sure. It can happen in some situations, probably, if it has to be processed anyway. But in my experience, cache hint is really great whenever you do an animation.
Okay.
It's one of the biggest and cheapest gains.
Okay.
I see a question if my workshop is will be online. Yes, it will be online.
And if somebody have no idea how to contact Tony, maybe you can say it again, and otherwise we're totally fine. So just contact the organizers and we will forward that to Tony if you are interested in joining this workshop. Maybe before we